Today on disease and epidemiology, okay, which is fitting because starting next week we're going to be doing the case study, so it's fitting that we end with a lot of these different, like understand these different terminologies and that kind of thing. Okay, so let's first talk about epidemiology. All right, so the actual definition of it is just the field that concerns of the geographical distribution and the timing of infectious diseases occurrence and how they are transmitted in nature. Okay. So this is very important in analyzing the behavior of a virus or bacteria. Like how is it spreading during the summer? Is it not spreading in the summer? This is going to allow scientists and doctors to start a prevention attack on the different diseases. So you know when to expect it to come. For example, how about the virus, influenza virus? We all know it reaches a peak during the winter season, right? And a little bit in the spring season. We know those are the two seasons where it's really going to hit everyone the most during the winter season, mostly the winter season, and leaks into the spring season a little bit, okay? And then as the weather starts to warm up, the transmission of the virus slows down, okay? This is what epidemiology is going to be focusing on, that kind of thing, okay? And of course, it includes the science of etiology, which is the cause of the disease itself, and of course, the investigation of the disease transmission, meaning the mechanisms by which a disease is spread. So we have to understand how it works, the machinery behind the bacteria or virus, and how it's actually being transmitted. Okay, where it actually goes. Okay, does it go to hotter climates? Does it go to cooler climates? Right. These are all the kind of things we want to think about. Okay, so let's talk about morbidity, okay? Now, morbidity is just basically the state of being diseased, okay? Now, there are two portions, two sections of morbidity. There's prevalence and incidence, okay? Now, incidence is just the number of new cases in a certain amount of time, okay? So using this, so we have this nice little bathtub analogy here. So the liquid here will be the prevalence itself, meaning the total amount of individuals in a population that has contracted this disease or illness in a certain amount of time. Okay. And the incidence is the amount of new cases being added. So it could be this faucet being releasing water, and that'll be the amount of new cases arising, and that's going to be added into the prevalence pool. Okay. Then, of course, this little breakage here, the leakage here, is going to represent mortality, okay? So mortality is the amount of people that actually die, okay? And then reoccurrence just means the amount of returning symptoms, okay? So how many people are getting reinfected again, okay? Now, I want you to know these two here, prevalence versus incidence, okay? Prevalence, how it's going to be calculated is your total amount of cases over the population at risk, okay? And then your incidence will be calculated as new cases over population of risk, at risk, okay? That's an alternative way of describing these two terms, okay? All right, so incidence is just new cases in a certain amount of time in the total number of population and relative to the population, and prevalence is the actual proportion of individuals with the illness in a population at a point in time, okay? So let's calculate more, okay? So let's learn how to calculate in a little bit more detail, okay? So in other words, using chickenpox in Boca, okay? And this will be the example of it. So prevalence of chickenpox in Boca is going to be the same thing as right now, how many people have chickenpox in Boca over the total population of Boca, okay? Right? And then the incidence itself, okay? The incidence itself, meaning the new cases of chickenpox in Boca annually. So every year, how many do we have? How many new cases of it do we have? Okay. So this means that how many cases of chickenpox is diagnosed in Boca within that 1 year? Okay, and that's going to be over the total population of Boca minus people who have had vaccine or have had chickenpox before. Okay, because this population here, this population is going to be immune. So these people are immune to it. Okay, So we don't take it into account. We have to subtract it from the total population, okay? Because remember, the total population hasn't been affected yet. They're not they're potentially not immune, all right? They're not immune towards it, okay? But for people who have the vaccine or have had chickenpox before, they're not going to get it again, okay? So you can't take those two values into account when considering the annual incidence, okay? This is statistics, yes. I'm sorry. Just a little bit statistics. It's pretty simple mathematics. This is literally the equation, okay? Is everyone clear on these two equations and how the incidence and prevalence are calculated? It's not too complicated. Okay. Now let's talk about mortality. I mean, I already mentioned what mortality is, and most people know what mortality means anyways, right? It's the death of, it's the rate of death from a disease or condition, okay? Now, whenever, like I say, in addition to calculating the morbidity rates, such as prevalence and incidence, we also want to look at mortality rates. So that's also very important, right? You want to compare the mortality rate versus prevalence and incidence, okay? And of course, it's going to be expressed as a percentage of the population that has died due to the disease itself, okay? Or it could be described as the number of deaths per 100,000 persons in the population, okay? So every 100,000 population of individuals, okay? How many dies out of that 100,000, okay? Yeah, just population samples, exactly, Henry. It's very simple statistics, okay? So let's look at this little graph here. Just zoom in. Oh, no, 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 not this. Here we go. Okay. So let's take a look at this a little bit closer. All right. So let's look at the maternal mortality rate in California between California and the United States. So we're going to be comparing and contrasting California versus the United States, okay, between the years of 1999 to 2013, okay? And the blue triangles will indicate the California rate of mortality, and the red bar will be indicating the United States rate, okay? So we're going to be using how many maternal deaths are there per 100,000 live births, okay? And the x-axis is going to be every year, so every 1 year, okay? So we can see here that uh, 7.7. This means that for every I'm sorry. Okay, let me go check. Take a couple steps back. So the numbers here represents how many people die per 100,000 lives. Okay, so over here you can see here that in 1999, California has had a lower rate of death than compared to the rest of the country. Okay, but as we go along, okay, they kind of go between each other, and eventually you could see that in 2009 it drops significantly. Okay, while as the rest of the country, when you take the aggregate country, it kind of increases. Okay, and there's cultural reasons, that kind of thing, health reasons for that, various things that go into that. Okay, so these numbers here mean that, like for example, 11.6 means that on average, okay, on that year, you have 11.6 deaths per 100,000 individual. Okay, this means you have 9.2 deaths, 7.4 deaths up here, 19.3 deaths. Okay, now there is another good reason why you see such a fluctuation with California. Okay, and it has to do with the sample pool, and Henry seems to know this quite well, that when you have a smaller sample pool, you're more inclined to extremity influences, right? Some unusual influences, as opposed to the total population. You're comparing a population of only California, right, versus the United States, which has over 300 million people living in there, during this period of time. About right. Right now, the population is 350 million, but during this time period, it was still over 300 million. Okay, and having certain outliers in a population pool of 300 million is not as severe It's not as consequential as that in only California. Okay, so California's gonna have more influences. Make sense, guys? I mean, you could see how it's how California is kind of it's almost inconsistent a lot of most of the time. Okay, it's kind of moving a lot, whereas the United States, the rest of the country, is kind of gradual. It's a more or less stable change until it reaches 2009, and it kind of increases more. Okay, but it's kind of steady. Okay, it's not you're not going. Let me erase this. You're not going from, let's say, from 2005, you're not going from here and only jumping up to 16.9 all of a sudden over 1 year. Okay? That's what I'm saying. There isn't that much massive influence or random influence because it's a smaller population. And also, you got to take into consideration because you look at only California, you got to take into account maybe, different complications that arise there, maybe earthquakes kill the person, that kind of thing. Okay? Uh, Make sense, guys? For this particular chart, I just want you guys to understand how to look at it. I'm not going to ask you anything super complicated from it, all right? But you could see this on the exam, like something like a figure like this, and I told you to analyze it. Okay. Now let's look at patterns of incidence. So remember, incidence is going to be the amount of new cases that we see in a certain amount of time, okay? And we could look at this today. We compare it to today. Okay, so let's look at this. Okay, so the first thing we have is a sporadic disease. Okay, now sporadic disease is you see it only sometimes, and there's no real geographical concentration of it. Okay, so it just happens once in a while. Nothing too serious. Okay, then we have something called an endemic. Okay, now endemic is what you see very very in higher frequency. Okay, that's constantly present, but in a certain region of the world. Okay, so for example, when we look at the Americas, right? The Americas, we're gonna see that a certain a constant introduction of new cases of a certain disease. Okay, but it's gonna be isolated to a certain region of the world. Okay, and this picture here, we're looking at the Americas. Okay, North America, Central America, and South America. Okay. Now, epidemic, okay? Now, epidemic is when you see a huge increase of number of incidents of a certain disease, okay? That would normally occur in a certain region, okay? So, for example, looking at letter C, okay? Focusing on South America, okay? For some reason, okay, if you have a sudden increase, like a huge increase of new cases of a certain disease in the same region, an isolated region, that's an epidemic, okay? Okay, so that'll be an epidemic. Now, a pandemic will be an epidemic, but on the global scale, okay? So a pandemic is an epidemic on the global scale, which is what we have right now with COVID-19, okay? Does everyone understand the difference between these four different terms? This is still a lot of this should be reviews, honestly, for just common sense, I think, so far. Okay? All right. So let's look at epidemics, okay? So we're gonna be looking at the influenza, all right? So now let me just take up my little marker. Now, so over here, this will be the year. So this is gonna be the year 2007 to 2008, okay? So this is the 2007, 2008 influenza season, okay? Now, over here is our national baseline. So this would be, about, 2.5%, okay, of the population that gets infected by the influenza virus, okay? But if you see this green line here, in 2007, 2008, okay, you see a massive increase of cases of new cases for influenza, okay? This will be considered an epidemic, okay? This will be considered epidemic. Now, do you remember when I showed you that picture of the mortality for the maternal mortality On this, I believe in this year, if we saw this year, we saw a little spike that happens, right? That's because a reason for that could be because an epidemic. If an epidemic occurs, you could expect to have an increase of mortality rate. That's just how it is, statistically speaking. Okay? So this sudden bump, unusual bump in a percentage of new cases, about 6%, okay? That means you have an epidemic. It's considered an epidemic because it's restricted to a certain region of the world. So it's gonna be in the United States. Okay. So we have this happened because we had an increase of emergency department visits for the flu-like symptoms. Okay. So that's an example of epidemic in a graph. Okay. So and in case you guys probably noticed, but each color represents a different year. Okay. 2007, 2008 is the green bar. Okay. And then the x-axis is the time of the year. Okay. Like for example, is it January, February, March, or April? Right. That would be the x-axis. Okay. So let's talk about early epidemiology. Okay. We're gonna talk about a little bit about a guy called John Snow. So he is the person who started this whole study, this focus of study. Okay. He was a physician. Okay. And what he did was his first attempt at epidemiology was to kind of isolate and study the occurrences region-wise of the cholera epidemic, okay, and on Broad Street, okay. So what he did was he looked at all the different contaminated water sources on Broad Street, and he kind of used that to correlate with a different new infection rate of cholera disease, cholera-related diseases, okay. And this happened in the 1854 cholera epidemic, okay? And that was due to the contaminated water resource, okay? The water reservoir was contaminated and it kind of spread around through this region, okay, in Britain, okay? And he wanted to analyze the behavior of this region, like where is it spreading? Can we contain it? Can we not contain it? Okay? That's why epidemiology is so important, okay? This area of science is extremely important and be able to isolate and study the behavior of these different viruses so that we're well prepared. Viruses and bacteria, okay? It's not only viruses. It's any kind of microbial based infection, okay? That happens, that could happen, annually or not, okay? All right, so let's talk about etiology and etiologic agents, okay? Now, the etiologic agent itself is the cause of the disease, okay? What's actually causing the disease? What virus, what bacteria is causing it, okay? Let's look at some uh, sorry, some of those examples, okay? So, Campylobacteriosis, okay? Now, Campylobacteriosis isn't caused by things like Campylobacter jejuni. You're gonna have you know, some ulcers, gastric intestinal ulcers. What else? You could have severe diarrhea, bloody diarrhea, and the annual. Let me see what it says here. So and well, this is gonna be only in the week of January 2nd, 2016. On that one week, they had 406 cases. Okay, the median of the previous 52 weeks is 169 cases. The maximum is 1385, and the total amount in 2015 was 46,000. So these are different values taken at different periods of times for the amount of people infected or afflicted with Campylobacteriosis. Okay, and this disease, and then we have also chlamydia, trachomatis infection. Okay, it causes chlamydia. Okay, and chlamydia is a pretty common infection. Oh goodness, this is really bad marker penship on my part. So the infection is caused by chlamydia. Okay, so that's the agent. Chlamydia is the agent here. This causes, in just 1 week, it caused 11,000. In 52 weeks, it caused 28,000. And the maximum, and I'm sorry, this is the median, okay, of the 52 weeks. And the maximum week, okay, the maximum is 31,000. And the cumulative cases reached over 1 million, okay? They have other diseases like gonorrhea and giardiasis. Those are two other agents, right? And those have various infection rate. Okay. because of this, okay, we have a government uh, controlled center that's going to be that takes close attention to the epidemiology of diseases, and that's the CDC, so the Centers for Disease Control and Prevention. Okay, it's part of the Department of Health and Human Services. Okay, and like I said, it's controlled by the government. Okay, and then we have something called the Notifiable Disease Surveillance System, which is going to be monitoring diseases that's going to be considered part of the public health importance on a national scale. So they're going to be looking at, for example, right now, okay, COVID-19. Okay, this is a kind of a it's affecting the entire country. So they're going to be monitoring these kind of diseases that are afflicting um, the country on a national scale. Okay, now such diseases like those that we see above here, and also the more severe ones, okay? They're reportable because all of them must be reported to the CDC, okay? They're not that means that whenever you see a notifiable disease, such as the one like the COVID-19, if you, for example, if you yourself, God forbid, got COVID-19, you have a duty to report it, okay? It is your duty to report it to the CDC. You gotta call them. Hey, I think I have symptoms of COVID-19, or I've been confirmed to have infected. It's your duty, as well as if you see a physician and they actually confirm that you had it, then it's their duty, okay, that they need to uh, submit a report, okay? So in this case here, a physician treating a patient with, for example, COVID-19, a notifiable disease, okay, by law, they have to inform the government, okay? So here's some examples: HIV, measles, West Nile virus, COVID-19 right now. Okay, those are the kind of things that that you have to notify. All right, make sense, guys? This is why epidemiology, that study, is so important. It's important for regulating infection rate to study that, and you know that has a lot to do with fighting the disease itself. Okay, it's a big part of the fight against it. Okay. So anything that's classified as notifiable means that it needs to be, you have to notify it. You have to notify the authorities, okay? And usually it's a physician, okay? But you could I do believe you can self-report those too. But usually you need to have a physician to determine that, to do the final determination. Um, anyways, okay. So let's talk about reservoirs or carriers, and we kind of went over this when we are talking about the virus chapter with zoonosis and the transmission uh, of different microbes via vectors and that kind of thing. So the first thing is something called the reservoir. Okay, this is where the disease pathogen usually resides. It could be living or non-living. Okay, so for example, the mosquitoes carry malaria parasite, that could be a reservoir, okay? That's considered a reservoir, all right? Now, carriers, on the other hand, are living only. So carriers have to be living. Reservoirs don't need to be living. They could be non-living. They could be inanimate objects, okay? For example, a contaminated water reservoir that has some kind of microbe in it, okay? Could have maybe Campylobacter or Helicobacter, okay? That would be a non-living reservoir, okay? Then, but carriers need to be living. They have to be alive, okay? Now, it could be several different categories. It could be an individual that's able to transmit a pathogen without displaying symptoms, such as COVID-19. So easy example, guys. You could be a carrier for about 14 days without displaying any symptoms, and then all of a sudden you're hit with the symptoms. Okay, and that's what makes COVID-19 so particularly annoying to deal with and dangerous because of the long incubation period. Okay, if people were displaying symptoms overnight, it'll be a lot easier to isolate cases of it and actually to prevent a pandemic. The reason why one of the reasons why it's a pandemic, the COVID-19, is because of its long incubation period, making it extremely difficult for people for the officials to track people. Okay. Okay. So we have two types of carrier. We have passive carriers and active carriers. Okay, passive carriers means that they're contaminated with the pathogen and can mechanically transmit it to another host. However, a passive carrier is not infected. Okay, that means that for example, a let's say I have some cooties on my hand. Okay, but before washing my hand, I shake hands with someone else and transmit my cooties onto another person. That other person then rubs their face and puts their fingers in their mouth, right? I went ahead and washed my hands immediately, right? That's what a passive carrier is. That means you contaminated with the damn pathogen. Okay? And active carriers, on the other hand, means you're actually infected with it. Okay? Your body's infected with this disease. Okay? And this active carrier may or may not exhibit signs of symptoms of infection. Okay? But you actually have you're infected with it. Okay? But a passive carrier, you're not actually infected. You're just contaminated with it. All right? And you can mechanically transmit. Like I gave you guys the example, shaking hands with someone and transmitting your cooties to that other individual. Okay, that's what a passive carrier is. All right. Now, active carriers who do not present any signs of symptoms are called asymptomatic carriers. Okay, even if they're infected with it. Okay, they're asymptomatic because they're not showing any symptoms, any kind of result of the infection, any kind of fever, right? Pneumonia. Okay, any of these things, bloody diarrhea, the symptoms go on and on. It could be muscle aches, right? All these different things. Is everyone clear on that? Reservoirs and carriers? Okay. So this is gonna be review, guys. Okay. Hosts, parasitic infections. Okay. We saw this picture before in a way earlier chapter. Okay. Now, the parasite's preferred host is called the definitive host. So again, just another definition. The definitive host is the parasite's favorite meal, okay, so to speak. Okay? And of course, parasites have various life cycles, okay? And the definite host is the host in which this parasite reaches sexual maturity, okay? So the definitive host, which is the preferred host, this is the only place where the parasite could reach its full life cycle and actually produce babies, so to speak. Okay, the next generation of those parasites. Okay, now some parasites may also infect one or more intermediate hosts, in which the parasite goes through several immature life cycles, stages, or produces asexually. Now, this malaria could be an example of this. Okay, an intermediate host. So the intermediate host would be the fly, the mosquito. Okay, the mosquito is going to be the intermediate host or the vector. It's also a vector. Okay, and it only goes through a certain section of its life cycle, and then once it enters the definitive host, aka a human being, then it's going to actually go through the entire life cycle, including the sexual maturity of it. And it's going to be able to produce some more copies of it. Okay? Is everyone clear on that example I gave you? And also, you have the example of glungal nema. It's another one. I'm just giving you a malaria example because everyone learned it already, and it should be you should remember that. Okay. Anywho, so direct contact transmission of disease. So it's going to be a mechanical version of it. Okay. Now this could be classified as okay. Sorry. Okay. So direct contact transmission of disease. This is mechanical. Okay, and this is going to happen from person to person. Okay, and things like touching, kissing, sexual intercourse, droplet sprays, and this could be via spitting on someone or sneezing, like inconsiderate people. Okay, if you're gonna be inconsiderate and sneeze or cough everywhere, that's what droplet sprays are. Okay, and droplet sprays, you saw that video I showed you guys in lecture before we left Barry for remote lectures, how far and how wide the area of of your sneeze or cough could go, especially your sneeze, how it goes, that aerosol effect, that's where, it's pretty nasty stuff. Okay. But of course, touching, right? If you touch contaminated dirt and you put that dirt in your mouth, right? You put your hand back in the mouth, right? Then you're contracting some of that parasite, microbes, virus, whatever it is. Okay. Kissing, for example, herpes. Okay. Sexual intercourse, syphilis. It could be other types of sexual transmitted disease such as AIDS, right? Now, we have two terms. We have vertical and horizontal transmission. Vertical transmission occurs when the pathogen is transmitted from mother to child, okay? And this means that this pathogen can penetrate the oh my goodness. I just went blank. I apologize. It could penetrate the womb, right? It could go right into the placenta, okay? So that's what vertical transmission refers to. The placenta itself is being penetrated, okay, by that microbe, whatever pathogen it is, and it's going to be passed down to the child, okay? And this could happen during pregnancy. So if it happens during pregnancy, it's it's crossing over the placenta. It can happen during birth or during breastfeeding. So if a mother is sick with something, usually if your mother is sick, you don't want to breastfeed the child. If the mother is smoking cigarettes, taking any medications, they're infected with some kind of virus or bacteria or parasite, that mother wants to avoid breastfeeding at all costs because all that stuff will be transmitted potentially to the child. Now, horizontal, on the other hand, occurs between one person A to person B, okay? Not mother to child, okay? So vertical, you're referring to mother to child. Horizontal is from, for example, from myself to one of you guys, okay? When I'm shaking hands with you. Now, we all saw this, and I'm not gonna we will remember that video, and I love that video a lot. And this picture here kind of shows you a cartoon representation of that. But I do feel like that video really spoke more than this picture to everyone, I believe. Now, when an individual coughs or sneezes, small droplets of mucus that may contain pathogens are ejected. Okay, and of course, this leads to direct droplet transmission. That means that the droplet that droplet containing the pathogen is to be directly transferred to a new host over a distance of 1 meter or less. Okay. Now, if it's greater than 1 meter, it's referred to airborne transmission. Okay. So airborne transmission would be larger than 1 meter. Okay. All right. I have a question for you guys. So, in the context of the COVID-19, okay, why does traditional face masks, like the surgical masks, why are they stopping the COVID-19 transfer? Why is it protecting your mouth, your oral cavity and your nasal cavity? Right. But how is it doing that? So, I don't know if you guys know, but things like COVID-19, the different viruses and bacteria, when they go airborne, they're usually attached in the air. They're attached to dust, particles of dust in the air. Well, it's a droplet. So you have to think of the droplets. You have dust particles in the air, right? You do have the droplets of mucus that kind of mix together. And remember, the virus and bacteria, they're going to be anchored to these droplets, either they're mucosal droplets or the dust in the air, right? They're anchored to that, and those dust particles get trapped on the fabric of the mask, okay, or the filter of the mask, okay? Make sense? Because they get trapped there, that means the virus or bacteria is not moving. It's a little cool thing. Okay, so let's talk about indirect transmissions, fomites. Okay, now fomites are things like a rock. okay? A rock or water reservoir, okay? It could be, your computer, keyboard. It could be a desk or a table. It could be your doorknob, right? These are inanimate objects that could facilitate transmission of pathogens, okay? So yeah, everyone knows some I already listed some examples. So doorknobs, towels, syringes. Okay, these are things that could be contaminated, some kind of pathogen. Okay, and if you touch them, and then you don't wash your hands afterwards, and you're more likely to infect yourself with it, whatever it is. Now let's talk about vehicle transmission of disease. Okay. Now, vehicle transmission of disease refers to transmission of pathogens through water, food, and air. Okay, so that's a vehicle will be a way it moves. Okay, so it could be air, food, or water. Okay, so for example, Salmonella or E. coli, that'll be a classic example of vehicle transmission potentially. Okay, if you eat a vegetable that's been contaminated with E. coli, that'll be vehicle transmission. Okay. Now, we went over this already before. Now let's talk about vectors, okay? Now, this will be a review from before. I spoke about this already earlier in the semester. We have two types of vectors. We have a mechanical vector and a biological vector, okay? The mechanical vector itself is going to carry the pathogen on its body from one host to another. This means that for example, a fly. Let's take a fly, for example, okay? A fly has bacteria A lurking on its legs, okay? On its legs, it's carrying some bacteria, okay? Some bacteria A on it, okay? It lands on your skin, right? Okay? That means that once it lands on your skin, it mechanically transferred that bacteria on its legs onto your arm, okay? The arm of your skin or something like that, okay? Now, and here's an example, okay? So let's look at letter A, all right? Fly picks up pathogen from fecal matter, okay? And remember, flies like to go on fecal matter, right? They like to eat the shit there. No pun intended, right? Now, once they go there, they could land on your food. That's why, guys, whenever you see a fly land on your food, I mean, you're tempted to just eat your food anyway, but just know that fly has been on feces, okay? And there's potentially some pathogens that's been transferred there, okay? That's what mechanical transmission is in a more everyday example, okay? Now, biological vector will be like a mosquito, okay? So the picture shows a mosquito. That's a good example, okay? It's carrying the actual pathogen inside of its body. It's actually infected with it, okay? It's infected with the actual pathogen, okay? And then once it bites the human, it transmits that pathogen into the human host, okay? So the mosquito example with malaria is the best example we could think of, okay? Infected mosquito bites the person gets sick, okay? That's biological vectors. Yeah, yeah, Christina, don't go eating. If you see if you're unfortunately if you got a nice hamburger from Shake Shack or something, get that one fly that lands on it. Me personally, what I do is 'cause I don't like throwing food away. I just take a knife and cut off that section of the sandwich and then eat the rest of it because I'm like that. Um, but yeah, I tend to just you could tend just to throw it out because remember you're eating poo potentially. Well, most likely you are. Let's be real. Okay. Now, let's talk about arthropod vectors. Okay, let's like cockroaches, right? I like to bring up cockroaches. Now, many arthropods, such as cockroaches, ants, flies, fleas, luces, mites, bed bugs, anything you could think of, ticks, right? These are all common vectors, okay? And here's a chart with just a lot of different examples. Okay, I'm not going to go through every single one of these, but I will definitely refer to this chart when I ask you on an exam to refer to, so give me some examples, okay? So you could just list some examples from here. You could derive some examples from here, okay? But the real message, the main message I want you guys to know is that there's a plethora of examples. It's not only the mosquito that could become a vector. You have a whole list of different arthropods, meaning bugs, that could transmit the disease. Okay? All right. Is everyone clear on that? All right, so last slide. Okay. This is a lot, and this has been covered in lab several times. So this is called healthcare associated infections, aka nosocomial infections. Okay. So for example, catheters, right? Various tools that you'll find in the clinic. They could be potentially contaminated, and you could contract an infection from those. Those will be known as nosocomial infection. Okay. It could be also invasive. So when you have surgery, for example, it's a good example. I gave you that example several times too. So surgery, tools being used, infected tools being used. This is all types of a nosocomial infection. Okay. Now, HAI stands for health associated infection. This is nosocomial infection. Okay, that's just an acronym for it. Okay, and the patient must have been admitted to healthcare facility for a reason other than infection. Okay, so that's how you classify it. Okay, so the actual infection itself has to be contracted. Okay, at the hospital itself to be classified as a nosocomial infection. All right. It's a particular part of the definition, okay? And you need to know this, all right? If you come, let's say you come into the hospital, right? And you stay there for like, let's say you're visiting a family member who got some kind of serious illness, or they come for surgery, right? And you want to keep them company throughout their entire surgery process, right? And you're there for a few days, right? And over the course of a few days, you got you start to display some symptoms, right? For maybe a cold or the flu, something like that. But you didn't contract it at the hospital, but you were carrying you're asymptomatic before you actually went to the hospital. Okay, but you developed the symptoms at the hospital. Okay, that won't be considered a nosocomial infection because you didn't contract the original pathogen there. Okay, you weren't infected with that pathogen at that point. Okay, it happened before you arrived at the hospital. You just so happened to develop that infection at the hospital, to develop the symptoms at the hospital. Make sense, guys? Okay, so that's basically it for this chapter, guys. We're done with this chapter now. For Wednesday, because we're finished, what I want to do for Wednesday, probably instead of having a lecture, I want to try a test on that Paracel material. And let me just show you quickly. Stop it. Stop